Hi, Sydney. Thank you for reaching out. I'm going to walk you through this problem where we're being asked to find the work required to move an object along a given path through a specific force field. And the very first thing that we want to do in this problem is we want to parameterize that path. So the easiest thing we can do is let x equal t. And if x is t, then we replace x right there with t. That's going to give us y is 9t squared. And our x values go from 0 to 3, and x is equal to t, so we also know that t goes from 0 to 3. We also need to write F, our force field, in terms of t, and we now have representations for both x and y in terms of t. So we've got to go into this force field, which is represented by the components y comma x, and we're going to replace them with what they are in terms of t on this particular curve. So the same force field, but written in terms of t, is going to have components 9t squared and t. And then finally, to get the amount of work required, we need to we need to integrate with respect to t, F, our force field, dotted with r prime of t, where r of t is this parameterization that we just got here. R of t is ti plus 9t squared j. That's just what we got for the x and the y from the curve. So we've got two vectors in terms of t. We want to take the derivative for r prime, take the derivative for r, and we get 1 and 18t. And we want to do a dot product between this r prime and this f, and that's going to give us our integrand. And we're going to integrate from 0 to 3. So for the dot product, you're going to multiply corresponding components. So I'm going to have 9t squared times 1 plus t times 18t, which is 9t squared plus 18t squared, so we've got 27t squared. And from here, it's just a straightforward integration problem. So we'll do a power rule on that t. So the new power goes up to 3, and we divide by 3 in front, which is going to make that new coefficient 9. If we plug 3 in, 3 cubed is 27 times 9. If we plug 0 in, we get 0, which is 0. So we've got 9 times 27, which is 180 and 63, so 243. There wasn't any units given in this problem, so we don't have any units to give for our answer, just 243.